Hey future toppers, this is me Aqib Afzal, and today we are diving into one of the most important problems in the mechanics. That's the monkey on a rope. That's a question from Concepts of the Physics by Aqib Afzal. So basically, this isn't just a textbook problem. Like, it tests your understanding of the Newton's laws, like the tension in a rope and the effect of the acceleration on the forces. It's conceptual gem, often like asked in the like JEE examinations, NEET examinations, or other competitive exams which you are going to appear like after your 12th boards. So basically, it's in like a question like thinking of a monkey that's climbing a rope. Sometimes like this monkey goes upwards with some acceleration. Sometimes this monkey moves downwards through this rope with some acceleration. Or sometimes what happens, this monkey stays on this rope. So what like happens to the tension? We have to find it. Like what happens to the tension when the monkey is moving like upside the rope, when it's moving downside the rope, or when it stays on the rope? We have to like find the tension in each case that will be built in the rope. Like, and I promise today by the end of this short video you'll like master it like a pro. So like let's grab your like notebook and break this a question. So if you will see a question, like question says like a monkey of a mass m, it's climbing a rope of massless string. You have to take this string that's climbing by this monkey. It's a massless and it will be hanging. So this string is fixed here, and this monkey will be climbing throughout this rope. And remember, this monkey has a mass m. So there are the four conditions which the question is asked, and we have find the tension that will be built in this rope in these four conditions. The first condition is when the monkey will be climbing upwards with the acceleration a. We have to find tension at that time. In second condition, we have to find when the monkey will be moving downward with the acceleration of a. We have to find the tension at that time. In a third condition, we have to find like the tension built on the rope when the monkey is actually stayed on the rope. It's not moving nor upwards nor downwards, but what actually happens, this monkey is like stayed on the rope. This will be the third problem. And in the fourth problem, like it says that the monkey is moving upwards or it is climbing like with a constant speed. At that time, we have to find the tension built in the rope. So let's go with the first like condition, that's monkey is climbing with an acceleration of a. So basically, if it says like monkey this is a rope, massless string, and this monkey of mass m, it's moving with the acceleration of a upwards the rope. So as you know that force is equal to mass into acceleration. So for the force here, you know that you will like upwards there will be the tension built, downwards there will be the mg. So this equation will be like T minus mg is equal to m of a. We have to find this tension. So what we will do this mg plus ma. Tension will be mg plus a. So from this equation, you'll see that the tension here the tension will be increasing as the monkey will be moving upwards with an acceleration of a. So basically what happens in this, look at this, the equation P is equal to mg plus a, which means that this tension will be increasing and increasing as the monkey will be moving upside through this rope. So this is the first condition. Now taking the second condition, in second condition what happens, this monkey is now moving downward with the acceleration of the a. So this is the second condition in which this monkey is moving downwards with the acceleration of a. Like if you like break this diagram, this is the monkey of mass m. Downward, this is the monkey of mass, and downwards there will be mg. Downwards there is an acceleration, and what towards the upper side there will be the tension built, and we have to find the condition of this tension here. So let's break this. The force will be like T minus mg is equal to, here what happens, we have to write minus m of a. Why don't we wrote here the plus ma like this? We write here a plus ma, but here we write the minus ma because the acceleration is towards the downside, and for the sign conventions we have to write it like minus. So what happens, it will be like mg minus ma. So tension here will be mg minus a. Look at now here what happens, the tension is here decreasing. In above equation the tension was increasing as the monkey was climbing, but what happens in this condition, the tension will be decreasing. Because why it is decreasing? Because the like gravity is helping the monkey to move. Okay, so why the tension is decreasing here? Because here the tension is decreasing because the gravity helps the monkey to move downside. And what, because why the tension was increasing here? Tension was increasing here because like the monkey was accelerating opposite to the gravity. So here gravity is supporting, here gravity was not supporting. That's why the tension here was increasing and here the tension is decreasing. Now tackling the third condition. Third condition says that the monkey is at a rest. Neither this monkey is moving upward nor downward. It's actually on the rest. So what happens? There will be the tension force built. Downwards there is the mg as the monkey has a mass of m. So here the tension will be mg. Tension will be equal to mg. So simple. There will be no acceleration as the monkey is stayed here. The tension will be equal to the weight of the monkey. Okay. So what happens here? Tension, not the tension will be increasing nor the decreasing, but tension will be only equal to the weight of the monkey. That's mg. And in case, now talking about the case 4, that is the climbing with a constant speed. So this is a monkey. It's climbing with a constant speed. As you know, during the constant speed, when the velocity is constant, acceleration is at that time 0. This thing you have to remember, like when the velocity is constant, acceleration will be 0. So when it says that acceleration will be 0, tension will be again equal to m of g. mg. So here the acceleration means, like if there is no acceleration here means a constant tension which will be equal to the constant weight, like same as that of above. So like always, what you have to now remember, you have always choose the correct direction wisely here and apply f is equal to ma. That's it, the question will be solved. And for more physics like hacks for the NEET and GE, hit subscribe and comment your like next debut. I am Aqib Afzal here, making the physics fun for you. Thank you so much.